A midterm soon, so I'm just going to describe everything we should know from for the first unit, which is 12.1, 12.2, 12.3, all the way to 13.1, 13.2. 13.2 not so much because the integral is not in there yet, which kind of their oversight on that one. Um, it's not really oversight, it's just a thought. Anyway, we'll start with the idea of what they call it again? A unit vector. A unit vector, which can be denoted by this. That's one way to denote it. But most people just denote it like this. How to denote it? Like that. Or they'll just say W is a unit vector, which is the most common way because everyone hates EV. Actually, I remember my high school teacher wrote it another way, which is so much easier. But this is a general formula over here. So the magnitude, so if I were to put, let's do 1j plus 2j, ij, and then plus 3k, which is the same thing as I did 1, 2, 3, 1, 2, 3 vector, which is going, let's see, x is over here, 1 over here, 2 over here, and 3 over here, and then making a thing like that. That's basically the vector, which you can also, if you really wanted to do it, not in the scope of this class, but you could do it, 1, 2, 3, and that would be a matrix vector. That's part of Math 18, which, yeah, it's fun to talk about. Not really, but it's interesting nonetheless. I really need to get some kind of paper towel for this. So the first question is basically, right, if we have this like that, it means that this, oh yeah, I forgot, if let's just say go back to this vector, the magnitude, it would be using the Pythagorean theorem, plus 3 squared, that'll be it. It kind of makes sense if you think about it. If you go 3D, you need something like this. So this magnet's tight on there. The first thing is trying to get this length, and then after that length you get this length, right? So this equation kind of makes sense. You can check it out later and prove it yourself. So the magnitude would be the length would be 30, because a unit vector means that you're shortening this into, if you combine the x, y, and z into a formula, this thing, it equals 1. Therefore, if I multiply this by 30, it would have the length of 30 because anything multiplied by 1 is increased by the amount that you multiplied with. That's the first idea I covered. Now, okay, so there's a few properties you need to know, like this one. So if this is 2v alone, if I do wx 2v, first of all, 2 could go to the outside of the rim, like this, like that, and then outside of the rim, like this. And if that's the outside, you could definitely do this as a negative 2 wx, sorry, that's wrong, vxw, which is contradicted by 2 vxw, and if we were adding, that would equal 0. Another thing to note is vxv equals 0. That means 2 vectors equal 0. Very common idea. And what else is there to know? V minus 3v, parentheses, let's just do that. Actually, let's do 2 and 3 over here. I think that's pretty, nah, I don't like that. Let's do 3 and 2 over here. And over here, let's do, what number should be good? 2 plus w, and then v over here. I think that's better. So if you look here and let's say v equal 1 magnitude, to make things easier, and this will be a w, sorry, that'd be w. Am I missing something? I am. I need w. Let's say that's a unit vector, so that equals 1 again, is the magnitude of that as well. So 3v square, so that's over here square, plus 3vxw, and we have to be careful because that's minus v wxw, which turns to positive because it's a reverse thing, because it was originally in this form. So you reversed it, which equals 7vxw, which equals 3 over here. So that's our plus 3 plus, what was this again? W was 1, so it has 2. That's 2 over here, so 2, and then 5 plus 7 vxw, and I chose this to equal 0. So 5, okay, so it's negative 5 divided by 7 equal vxw. Very simple. Very simple. I really need a better way to erase this shit. It's actually impairing my ability to actually write something decent for once here, which I don't like. So anyway, what else do we need to know for the first test that I can think about? Oh, right. Dot product equals magnitude v w magnitude with the cosine with the angle. That'll be very useful, because if you have two magnitudes and you can figure out a way to get v dot v, you can always get the angle. Important idea. And another idea is the magnitude of, oops, that's wrong, magnitude of a cross product equals a v to w sine of theta. So this is an interesting idea. You just, if you have been studying properly, you would know this one. Yeah, very, very simple idea. And there's also a triangle formula, which is angle v theta angle divided by 2. I believe what was it again? I forget. Who cares? Parallelogram. Sorry, parallelogram is something like this, which is fine, which makes sense. It makes sense. And a parallelepipedoid is the determinant of three vectors with a unit vector, which we could just do a determinant with the 1, 2, 3, 1, 2, 3, 1, 2, 3, and if you have 1, 2, 3, 1, 2, 3, 1, 2, 3, that equals 0, which is common. But if I had changed it to 4, let's just change it to 5. It's no longer 0 anymore, and this would be a valid substitute to make a something like that, which no one gives a crap, but it's part of it. Part of the lesson here. A lot of people give a crap about that. Then there's a line topic that you need to know about. It's a very simple line topic. I have talked a lot about it. I mean, I didn't, because there's a lot of things. But the idea is you need to figure out 3 points to get any plane. So if you have 2 planes, you want to, or 2 lines. So let's just say you get a plane and a flipping line like this. That's somewhere outside the plane of existence. Okay, like this. Like this. So let me get a question out for this one. Let's just say find the equation for a plane that contains that doesn't make sense. Equation where the plane is that'd be an interesting question. We'll talk about that one later. Find an equation that contains. That's easy. No. Well, I don't know what I'm talking about. But this is the idea of, if you get the point over here and point over here, which you can do this. It's not 90 degrees, but you can get 2 vectors and make a plane over here. This is a very interesting idea. So if I had 2 planes like this, just any plane, and you want to get the line over here, which is the infinite line, which like this. What the hell is that? Oh, that's the Pipitoid to talk about. And the angle could be really different. So let's just draw a very irregular angle, because I want to talk about an irregular angle and conceptually try to figure out what kind of possible shenanigans you can do to get this point over here, which It's interesting because the only thing you have is the end point, which end can be two different directions like this, which with the point over here, end point can actually be anywhere in the field, but you have to think, what the hell does this actually mean? What the hell does this actually mean? What do I do? So if we're talking about the line that connects two planes, we know that really just means that the x, y, and z shenanigans equal each other at those segments, right? For two different planes. So let's just say x plus y plus z equals 0. And let's just say, whatever question, whatever. Let's say x minus y plus z equals 0. We could interpret that as just simply, well, we could do the minus game and do 2x plus 2z equals 0 and do a more confusing equation, which, yeah, you can do that if you want. I don't think I want to. And instead of doing that, I think I would take the path of x plus z equal y and x, and then we'll just plug in y2 over here, which y equals 2x plus 2y to z equals 0. You can see it's the same thing. That means basically 2x equal to z, right? So I can divide by x equals z, which means their t and t should work for that. Unfortunately, y is not so lucky. Yeah. And then we have this problem over here, which gives you 0 equal to y. Over here, which means y equals 0. Interesting idea. So 2y is giving over here. Then we get this formula, which gives you 2i. Interesting idea. Very, very simple. In the end, figuring that out. Just follow the math, basically. I need to get something better than this. Other things I should mention, which parallelize, get a point over here, get a point over here, get a point here, get a vector, or whatever shenanigans. I think you figure out getting 3 points in any. I didn't get the plane, so whatever. Another thing is intersecting surface, which, that's a little bit of painfulness. So it's called parameterization. I don't really want to talk about it. Let's just make up some numbers equals 0, and then over here we can say fuck it and say z equals t because I'm lazy, but z equal t literally anyone could say, so why not do x equal y instead, x equals z instead, and say z equal t just because we can, which means t over here, which means x is t, which means t plus y squared equals 0, which means y squared equal negative t square root, which square root cannot be, so that's wrong. Yeah. That cannot be possible. So t has to be negative, so negative time. Shit, something I did wrong here. T over here. No, I did something wrong. Well, that's gonna be a weird one to talk about. But if I did trigger things, it should equal way easier than what I did. Sine t automatically we get. And why not z equal t? That's what you should get for the trig way. Now the algebra way is kind of a little bit confusing why it's not working, and I don't understand why it's not working. Oh, shit, it's a square, dumbass. Which means there's minus square, which means you can square root it here, making things easier. And then negative t square, so it's negative t. Instead, let's just make our life easier just say negative t, it works. Because if you think about it, t can be negative and positive. It doesn't really matter. It's infinity, which kind of works. Yeah, I think you could choose a better argument, but I'm lazy and I don't want to actually. And it's like at 10 o'clock right now, so I have a test at 8 p.m. tomorrow, so I don't really want to do anything shitty like that. But yeah, so the next one is the idea of a derivative and a point. Very easy, simple. Oh, there's also something about if you do this. Don't worry about that because it's not in this class, as physics instead. And there's something like this about electrons and the point vector there. That is how electrons interact. What else is there? I don't know. We can talk about that for in particular time. But if we have a point over here and a swirl over here, something like this, and we want a 90-degree angle, it really doesn't matter which way you go because it will make a line. So I'm just showing it that way. It usually is shown going this way when you do a slide. I mean, you get what the point. I don't need to draw it 3 times, because it's an infinite line, and it can. In our structure, there can be negative time, but in physics there can't be, which is a pain in the butt when you do physics. I don't want to talk about it right now. So over here, let's just say that's 1, 2, and let's say the line is something like t squared plus comma t, comma whatever t. Just so you know, if I had that's the x version, so x is this way, x and y, x and z. So x and z would make it so this way over here, something like this, would project over here if it was if you got rid of the something. And yeah, you don't need to know. But 90-degree over here, actually it shouldn't be 90. It's tangent. What am I doing? Tangent to here. So this is OP, which is a vector going to over here, which is just this, and then you need to derivative this, which is 2t, and then t, which is 1, and then 1. So the final vector would be you plug in that. Sorry, actually I needed 3 over here because then you plug in that because the constant no t, then you get deleted to 1, 1 as our derivative, and over here we have the derivative here, so it's 1, so it's 2, 1, 1. Very simple. Very simple. And for that, you can also have a question with acceleration, velocity, and blah, blah, blah. You kind of get the point. I think you got it all, so I'll stop here. If you have questions, I don't care. I'm tired.